Good afternoon to everyone. We are doing this speech together. Me, Guillermo Resil from Formal Vindication, and my colleague, Yannick Foster. He's a researcher, one of the main researchers of INRIA informal method. And we are just showing here how our collaboration gets results in the field. Okay, then we will talk about the first ever implementation of a computable law completely formally verified, and it will be the 561 regulation through what we call PCSS method. We will explain everything. Okay. First of all, a long time ago, we reached the concept of computable law, which for us, the definition of computable law is a law or regulation which goal is to be a specification to develop software to control something. I mean, if we have this definition, the 561 is a perfect one, and the 165 is as well for tachograph. They are laws to be a specification to create a software. Okay, then later we realize that, for example, in Stanford University, there was a group of mathematicians and lawmakers that they call computational law. We call computable, they call computational law. And it's a little bit different because they are talking about the legal reasoning, automatic or automata, lawyers, automata, judge, these kind of things. It seems that both fields are different, but in the end, they are the same fields. And we will talk about it. For us, any computable law should be, I mean, the relation between a computable law and software should be, first of all, the law must be consistent and deterministic, not to have an interpretation. Second, should be proof that the software is exactly like the law. And for me, the third definition that is concerning me more with my experience is that we shouldn't allow any engineer to take a decision about the software that is not in the law. And this is especially critical in many laws, that the software engineers are taking decisions that they are not in the law. Okay. According to that, we will show the PCSS method to certify software and a product, the 561. Okay. Then let's see some example of the critical software. We have first the Ariane 5 crash. We have recently the Schiaparelli crash in 2017 in Mars. We have more, and we have a possible example on a policeman controlling a tachograph on the road, and because of the software have a bug, can put the driver on the jail, can put a big fine, or maybe because of the accumulation of good reputation, the company is losing the transport license. We know already, I know already, American companies, US companies, they lost the carrier license. For you, which one of them are more critical software? In my opinion, the control of the road. Because the 1 and 2 is only about the money. In Schiaparelli, Europe only lost 3,000 million of euros, nothing else. But when we are talking about human right, I think is more critical. Okay, then the question comes: is there enough human knowledge to certify homologate software? Okay, here we will present our method and implementation together with INRIA and a product already. Okay, then the PCSS means public certification of a specification and its software. Then the definition should be that the software is based on a formal specification, which means the software itself is nothing. We want the software to do something, and this is a specification. Then we cannot, when we are talking about software verification, we cannot talk about the software, we can talk always about the pair, specification and software. The formal specification is mathematically proven to follow all mathematical properties. The formal specification follows the computational limit. I'm going to the 5. The formal specification should follow physics, the physical parameter. For example, in the Ariane crash, it wasn't really a mathematical issue, it was a physical interpretation of one parameter. Then, if we are taking 1, 2, 3, and 5, everything is about a specification, a good specification. Then the next definition should be the software, the fourth. The software is mathematically proven to follow the formal specification. Then the software is not important. Important is the specification. Okay. If we are taking from 1 to 5, I would call that private certification. I can do by myself. But the issue is that I want to share, to do it public. Anyone can certify the software. Then we are adding something else, that the formal specification has an equivalent formulation and interpretation closer to a natural language. This is, I will go later about that. And the second one, that any team can do that. Any team with enough knowledge can do that. Okay, can we make that technology? Yes, we can. This is the implementation of before theory. All it is in a blue background. This is made by a proof assistance called COG. And here we have Janet that will explain what is COG. Okay, COG is a proof assistance that can guarantee most of the things of the chain. There are many proof assistants. There are some proof assistants in the world. There are Agda, Isabel, Microsoft and Amazon, they have the Lean, they own one, but this is, COG is the most powerful proof assistance in the world. This is the biggest knowledge informal method, and is made by INRIA. Recently, I have been in the NASA formal method, and 66% of the formal method shown there, they were talking about COG. This is amazing power, and it's the only one who is fulfilling everything. But this is not enough. This is not enough. And I will go to the next screen. Okay, think about, and for law, this is very important. Think about the formal language down. This is not mathematical language. This is not software. It's a formal language, a formal specification. If I am putting this in the chain, in this chain, it will be in sigma. In sigma. This will be in sigma. The question is, if I am putting in the sigma, I can prove that this is perfect, this is perfect, the software is running according to that, this is made by COG, and everything is perfect. But the issue is, I don't understand that. I can prove, but I don't understand. If I am going up, a function that short a list of numbers, I can understand up, but I cannot prove that. And this is a big issue. What we can prove, we cannot understand. And for legal reasoning, this is an amazing problem. But I think we found our solution. Let's see that recently, I mean, many years, there are the best researchers in the world trying to find a solution to link natural language and software. A specification. There are. Recently, we have been working with FRED. FRED is a tool made by NASA, and all reached until now is extremely poor in expressivity. Then we realized, we took a decision. It is not possible to prove that natural language of some equivalent languages, that is not necessarily natural language, is exactly the same of formal language. Once we decided it is not possible in general to prove, we opened everything, we saw the clear future, and we found our own method that can interpret any kind of abstraction language, any kind of specification. Then, if we are going here, with the FB fee document, we can, from the natural language, follow all the chain and to check that the software is running according to, let's say, natural language. Okay. This is the method. let's go now to implementation. Let's go to an object. If we are taking the 561 regulation, if we are applying the public certification of software and software, we get that. What is that? I mean, I won't explain you, but this is our certification. Then, who can understand that? I say that our software is according to the 561, is perfect, and anyone can do it. And this is the result. I can give this to anyone. Who can understand that? Who can understand that? Okay, according that the people I know, if I would be a Danish authority and I want to apply that in Denmark, there is a group of mathematicians that they can do that. They can certify that in Aarhus University, for example. In German, there are a couple of groups in Germany, 2-3 groups. France, of course, they are full of groups in France. In Spain, there are, I think, 2 groups. In USA, there are a big group, a really extremely good group in Princeton. I mean, there can be, by groups, any other groups of mathematicians with enough knowledge can certify what I am certifying, but they are not much in the world, okay? But can be done. Now, let's do how we did this implementation to the 561. Let's go to things to understand. What we did before doing the formal specification, we did a framework, a mathematical framework to be implemented as a specification. Then, this framework, one framework, is covering the European Regulation 561, the USA Federal Act 395, the Canadian 313, the Mexican that, and the Brazilian several laws. We can do everything in the same framework, because we discovered that all lawmakers have the same mentality. Okay, then how we did? I am going to the last point. That, okay, it's not, I cannot see, moment. Okay, I will read you this, the last part. The thing is that if we are taking the 561, I cannot implement in a framework. I cannot implement it. Because the 561, there are many articles are inconsistent and undeterministic, non-deterministic. Then what we did is we took the law, the regulation, we didn't add anything, because remember, I said, we will not create in the software, nothing is not in the law. This is for me critical. Then we took the law, we take away some articles that they are inconsistent or undeterministic, and we took a subset of the 561. Okay, I will follow a little bit. For example, the issue of the single team driving mode, we solved it partially. We didn't give a total solution, because I think I would be a lawmaker, and we don't want to be a lawmaker. This is clear. Then we do some partial solution for that. For example, for the UTC problem, I mean, the law is clear, must be in UTC. But there is no time in the tachograph. The tachograph, there is the time real, this one. This is what is in tachograph, the time real. In any software you are using time format, is true or not? How is made the conversion? Okay, then we guarantee that the conversion we did in UTC, not in Unix. What is Unix? Tachographs are working in Unix, not in UTC. Normally, the software used by everyone for Reddit, they are working in Unix, not in UTC. And okay, then you say me, are you sure that you are doing that? Okay, we are based in this protocol for that conversion. And this is used by all the aerospace industry, which means Javier Simon, the guy who talked before, they are using this protocol. And they are working in UTC. But the tachographs are not working in UTC. And if we want to have something formally verified, We should guarantee that should work in UTC. What are the consequences to work in UTC or in Unix? It is proven that there are some ways to drive by drivers that a tachograph based in Unix can register all the time driving, but in UTC is rest, 100% of difference. There are. Then we can guarantee that we do everything in UTC. Okay, Guillermo, you said that. Can you prove that? The week before, we presented in CPP, Conference of Formal Method in London, this solution. It was reviewed by 3 main researchers. They were accepted, and we published in the conference the result. Then we have some certification, okay, for that. Let's follow. Basically, in our framework, this is the mathematical language we are using. And I will tell you what are the subsets we are taking from 561. In the continuous driving time, we are only taking the first paragraph, not the second one. If we are taking the second one, we cannot prove that the specification is running according to the article. We cannot do that. And because we are working in a formally verified software, something that we cannot prove, we will not do it. Which means any software who are using this article, each of the software engineers are developing his own definition and different one from the others. But our team prove that our software is running according to the first article, not the second paragraph. Okay. Let's go, okay, is working in UTC calendar. Also, we did a subset in the condition of the daily driving time and the daily rest time. We did. Why? I think the 561 is clear about the driving time period. It's clear that you can drive, for example, 2 times a week until 10 hours. Yes, it's clear that. And if you are driving 3 times more than 10, it is more than 9, it's an issue. There, we have that. But what about if we are applying the regulation 2022694? The severity. Okay. I will tell you one thing. For me, it's crucial that the engineer not take decision out of the law. If not, the engineer, the software maker, is the lawmaker. And this is, for me, crucial. This is quite a little bit corruption, I think. Okay, then think about that you draw, to explain this, because you will understand that. You draw on Monday, 9 hours and 1 minute. You draw Tuesday, 9 hours, 30 minutes. And you draw on Wednesday, 10 hours. Is legal? No, it's not legal. This is clear. But when you are asking to the system, what is the severity, what is the exceeding time, the correct answer is no answer. It's no answer. Why? Because you don't know how to calculate, because it will depend on the order. The order, you can change or not the order, depend on your interpretation that is not in the law. That we will not apply that because it's not in the law, okay? We will not take any decision that is not in the law. We are not lawmakers. Okay, I'm sorry, then I will finish my point. Then, think about what should a driver receive as a proof of an infringement in a system full of guarantees. Think about the case of Misura Ridota in France, Pronto Pago in Spain, ININ in Belgium, Amende Forfaité in France, and in Denmark, I think it's called pleading guilty. In those cases, the driver is fined, and they have not any legal defense. Have they got any right? Have they got any? What are the rights in this case? Okay, for us, in this a system full of guarantees, should be something like the DD files, of course, but then the JSON, the input files that you recognize the manipulation you are doing from the DDD files in JSON input, the output result, the HA file that, in a way, you are signing that the input JSON is according to the output JSON, and no one can manipulate that because you can test that is manipulated. Also, a certification of INRIA, how COG is working, and certification of formal vindication, how the system is working. For me, this is a package for the driver that you are fine, and this is the reason. And you can test by yourself at everywhere with all the guarantees. I don't know if here, again, 1-2 minutes more, maybe? Me or not? Okay, then, I don't know if I can explain. But for example, I don't know how to say. Okay, for example, let's say you have in a DDD file 2 different activities in the same second. This is impossible. But it's happened. Then someone should take a decision in JSON files. There are many kinds of decisions that a software maker are taking, and we need to recognize here. Okay. For example, the control concept. The control is based on 21 days, I think. 21 days. But what does it mean 21 days? Can you take info before of the first day if the infraction start time is inside of the period? This kind of thing should be put clearly in the JSON input. All the parameters you are to control and to have the output file. Okay, this is basically what we reached. I think we already start implementing that in private companies in February, and I think until the second middle of the year, I don't think will be implemented by any enforcement agency. Okay, then this was my speech. And I will pass the word with Yannick, that he will explain what is COG and what is base our technology.
Yannick, please be brief. We've already, yes. Thank you.
I'll be brief, and I'll only have pictures and no complicated things, because Guillermo asked me to quickly talk a bit about the tools they have been using that are kind of the, let's say, state of the art, if you want what I'm saying here, highest possible trust in programs. And he mentioned a couple of times this word formal methods up here. And I think if you're developing software, this is small on the left, so I will read it to you. The thing if you're developing software, for sure, no matter what software, you're going to test it a lot. That's because testing can be done automatically. It is fast, it's kind of trivial how to do it. The problem is that when you finish, you probably still have some mistakes in your program because you didn't catch them all. Many, but for sure not all. So this is all the thing, the software Guillermo was trying to sell, and the story for rockets like he showed. The story is how can you make sure that there are 0 mistakes? And then there are a couple of methods where you go up and you can do model checking, automated verification, or you use proof assistance like he mentioned, or you mention other things where the things become mathematically more involved and a bit more slow. But in the end, we can reach a state where we can basically say, this is the specification of the tool, and we have the highest possible guarantee that this tool fulfills exactly this specification, because everything that's involved in this process was certified using mathematical methods and computer checked. And because we're a bit short of time, let's skip this. I'm mentioning that this is the COG proof assistant, which is a thing that has been developed about 40 years at INRIA, which is, I didn't say that, the French National Institute of Computer Science Research, by a big team of researchers all over the world, most of them actually researchers that choose to spend their time, their research freedom on these kinds of things. And then I think I'm going to leave you with this and the story that if you want to get higher guarantees, we have these ways, and Formel V is using them to get kind of the highest possible trust nowadays by having proof assistants like COG in this development.
And just to finish one thing, I think we reached enough knowledge to do the formal verification or the certification of any high-level software language. Now we are thinking to move in the low-level software. Then, here there are 3 tachograph producers. We call Continental, Stone Age, and Intellic. we launched the idea of collaboration to develop a formally verified software to control tachograph according to our method. It's a multidisciplinary job. It's a research, but I think we could get formally verified software to control hardware. I think so. The tachograph in this case.
Thank you very much